Hello friends, welcome to the session on artificial intelligence. In this session we'll be discussing about regression analysis. Friends, you will find that whenever we write algorithms for the artificial intelligence, then many times we need to predict a value based on another value. So for example, if you have been given the rainfall of last 25 years, then based on that data you can predict what can be the rainfall next year. So such type of the prediction can be made by using the regression technique. There are different regression techniques available. In this session we will see what are these regression techniques and how they can be used to predict a particular value. Friends, as you know that you are viewing my session on my YouTube channel, and you can record or you can subscribe to the channel so that you can watch many other educational videos on the various topics of electronics and computer science. So let us start the session and let us understand what we mean by the regression analysis. Friends, you will find that regression is very useful technique because it is a kind of supervised learning task. Already we have discussed what we mean by supervised learning. So regression, you can say, is a supervised learning technique. And here the goal is to predict a continuous numerical value based on the input features. So when certain input features are being given, then based on the input features you can predict the value. As shown in this window, you can observe that these are the different data points that are being plotted, and based on this we can draw a line, and this line can be called as a regression line, and this regression is being called as a linear regression. So the model learns the relationship between the input variable and the output variable. So the key characteristics of the regression analysis is that it can predict a continuous value, and it can be evaluated by using the matrices like mean squared error, MSE, or R-square score. And this regression analysis is very useful technique, and it is used in forecasting, or it is also used in making the trend analysis. So there are different types of regression. Say for example, we can have a linear regression. As I said, regression is a predictive modeling technique, and it basically what it does is that it determines the relationship between the dependent variable. The dependent variable is being called as a target variable, and one or more independent variable, and independent variables are being called as the features. In linear regression, we can establish a straight line relationship between the dependent and independent variable. Say for example, we can write the equation for linear regression as y is equal to b0 plus b1x plus epsilon. So by writing such relationship between the different variables, we can predict the value of the y. So y is the predicted output, x you will find that is the input feature, and b0 is the intercept, and b1 is the coefficient or slope of the line, and epsilon is just nothing but the error term. So here y is just nothing but the output, x is the input, b0 is the intercept, and b1 is the coefficient or slope, and epsilon is the error. So this linear regression can be plotted as shown in this diagram. Say for example, if you want to predict the house price based on the area available, then you can predict the house price. Or whenever we want to estimate the person's salary based on the number of years of experience, then it is possible by making the use of linear regression, we can estimate the salary of the person based on his experience. So these are the applications where you will find that the linear regression can be used. There is another technique called as the multiple regression, where you will find that it is an extension of the linear regression, where there are multiple independent variables used, and they are being used in order to predict the value of the dependent variable. Say for example, if y is the dependent variable, we can write the equation b0 plus b1x plus b2x dot 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 bn xn plus epsilon. So say for example, if you want to predict a car's fuel efficiency, then it can be predicted based on the weight of the car, engine size and the horsepower. Or whenever we want to forecast the sales based on the advertisement that is spent on the advertisement, the product price, and then the economic conditions. So multiple variables can be used, x1, x2, x3, and by using these multiple variables, we can predict the value of the y. There is another regression technique called as the polynomial regression, and this polynomial regression will model the relationship between the variables as an n-degree polynomial, and it is very useful for capturing the non-linear pattern. Linear regression or multiple regression is suitable whenever there is a linear relationship, but whenever we do not have a linear relationship, say for example as shown in this diagram, when we have a non-linear relationship between x and y, then such polynomial regression is very useful, and the equation can be written as y is equal to b0 plus b1x plus b2x square plus b3x square plus dot 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 bn x raised to n plus epsilon. So for example, if you want to predict the population growth over time, then it will normally follow a curve rather than a straight line, and therefore here we can make the use of this regression. Or whenever we want to model the relationship between the temperature and the electricity consumption, then here also we can make the use of this regression, polynomial regression. Another regression that is also very popular is being called as a logistic regression. So it is used actually for binary classification problems. So whenever we want to have output either 0 or 1, then this is being used. So the logistic regression will have the shape like S-like curve, where you will find that the function can be written as p of y is equal to 1 is equal to 1 upon 1 plus e raised to minus b0 plus b1x1 plus b2x2 plus dot 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 bn xn. So here we can predict whether the customer will buy a product or not based on the different variables, or we can diagnose a patient as a diabetic or not based on the different test results. So there are different applications where you will find that the logistic regression can be used. So thank you friends for viewing the session. Hopefully you have understood what we mean by the regression and what are the different applications where it can be used.